This week we're going to talk about the relational model in a bit more depth than we have in the past. So let's begin. When we say the term relational, we're really talking about how things are stored within a given database. The relational model is built upon the idea of tables, where data is organized into rows and columns. This idea originated in mathematics about 45 or 46 years ago. And there are two facets to this model. One is the relational algebra, and one is the relational calculus. In this course, we focus on some elements of the relational algebra, because those are translated into real, tangible things in SQL, among others. We're also going to be concerned with the three aspects to the relational model: structural, manipulative, and integrity. These three aspects are the core of the model and really what we're concerned about for the things we're going to do. So let's take a look at each. The first aspect is structural. How is the data actually stored and organized? Well, data is perceived by the end user as tables and only tables. In other words, tables are the logical structure of the database. Within these tables we have rows and we have columns. Each row represents what's typically called a data record. Each column is typically referred to as a field or an attribute. The intersection of rows and columns are called cells, and in these cells we store what are called discrete data values. Some other terms that we often hear about when it comes to the structural aspect of the relational model are the terms degree and cardinality. These are used to describe a table. The degree of a table is the number of fields, or the number of columns. The cardinality of a table is the number of rows. We also heard the term domain thrown around a lot when it comes to the structural aspect. Domain is used to describe a field. It's a set or a pool of valid values for a particular attribute or attributes. As an example, consider your major here at Penn State, and if you don't have one, eventually you will. When you are assigned or opt into a major, you are assigned a major code. If this was a field in a database, specifically a major field within your particular student record, the pool of valid values would be the set of all possible major codes at Penn State University. That would be the domain of the major field. Here's a simple example of a table, just to give you a visual indicator of what this might look like. This particular table, which stores city information for Pennsylvania, is taken from Microsoft Access. We have rows, each of which represents a record, and we have columns, each of which represents a field or an attribute for the given records. The second aspect of the relational model is the manipulative aspect. Here, we start to look at how we can operate and manipulate data and what that produces. Table operations have the closure property. In other words, operations on tables yield tables. This is the manipulative aspect of the relational model. Any operations performed on tables yield tables. This is similar to closure properties in mathematics. For example, addition with integers yields an integer. This is usually implemented through SQL, and there are three common operators that we're concerned with. Now, these operators come from the relational algebra: restrict, project, and join. When it comes to implementing them in SQL, we actually only use one keyword to help us do that. The restrict operator is the primary operation, the one you'll certainly use the most. It's sometimes called select because that is the SQL keyword we use to actually do this operation. When we use restrict, what it does is it selects out a subset of the rows of a given table. If you recall perhaps from prior coursework, a subset is only a portion of a set. It's a piece of the whole. The SQL select statement and the SQL where clause allow for restriction. Now, the idea with these two particular pieces of SQL is that you can select out a subset of the rows of a given table using select, and we use where to actually specify the criteria which allows us to pull out that piece of the larger whole. Here's an example. In the top you see really a portion of the large table identifying city information in Pennsylvania. If we only wanted to pull out those cities that are located in the county whose ID is 3, we could do that using the restrict operator, and we would produce the results shown at the bottom. A 4-row table, in other words, the cardinality of this particular table, or result I should say, is 4. The degree is 6 because there are 6 columns. This is an example of restriction. In other words, pulling out a portion of the larger table, a subset of the rows. The project operator allows us to select a subset of columns from a given table. This is often used in conjunction with restrict, but doesn't have to be. As an example, again at the top we see a portion of the larger table with 6 columns. If we want to do a project, only show 2 columns, the name and the population of each city, we could do that, and we would get the result in the lower right. The result shows a subset of the columns. In other words, only a portion of the columns. This is an example of project. In SQL, we also use the select statement to do projection. The join operator is the most complex of the 3 operators, and the idea here, as you might expect, is to bring things together, specifically to derive a table from the merge of 2 or more base tables. Now, joins usually occur based on common values in a common column. In other words, they need to have something in common, and we join them together based on those particular columns. We need some way to match up the records. It's that common column and the common values therein which helps us match things together. And often these things are used with restrict and project. There are 2 types of joins that we'll consider in this course. And to give you a brief example of them here, we have inner joins, and these are commonly used interchangeably. That word is commonly used interchangeably with join. And the idea here is that the table returned by the operation includes the rows which meet the join condition. In other words, we usually match different rows between the 2 tables based on that common value in a common column. An outer join is a bit more inclusive. It means that if there are any rows which do not meet the join condition, in other words, that don't have a match between the 2 tables in that common column, they are included in the result anyway. Again, this is a bit more inclusive, and sometimes it's useful to have this. More often than not, we focus on inner joins. The third aspect of the relational model is integrity. Now, generally speaking, this means the assurance of valid data. Now, valid is a subjective term, depending on the context. However, the idea here is that the database will ensure integrity as it's been defined by the database designers. Each cell must have a value, and that value must be valid. Now, last time we looked at the 3 levels. We looked at conceptual, physical, external. Well, integrity is implemented at the conceptual level via integrity constraints. Things which restrict the values that can go in a particular field, or other integrity constraints that are enforced at the table level. Something we'll explore more in the future. Keys act as constraints. They limit the ability of duplicate data to enter the database. Now, there are many different types of keys, and you'll read about some: candidate keys, primary keys, foreign keys. There are 2 main categories that we're going to consider in this course. Primary keys are 1. These are 1 or more fields which uniquely identify each record. It's important to keep in mind that with primary keys, they're designated as primary keys, meaning they're the main way in which you can access the individual records within a given table. However, you can have other keys which have unique values or uniquely identify each record, but are not identified or designated as a primary key. In the end, primary keys help to ensure entity integrity. Foreign keys, something you considered last week, are 1 or more fields which reference a value in a field of a record in another table. Hence the name foreign, referencing something outside the table. This helps to ensure something called referential integrity. The referential integrity enforced by foreign keys means that data is not permitted into a field unless there is a corresponding value stored in the corresponding column of the reference table. Now this is a mouthful, and it's an even somewhat abstract concept to wrap your mind around, and so we're going to hit that a bit more as we go forward in the course. Here are some formal definitions of two terms we just mentioned. Entity integrity, which really means that no two rows have the same primary key value, and that there are no null or empty values in a primary key. Referential integrity, which we just mentioned, foreign keys must match field values in the source table, or the reference table, however you want to refer to it. However, foreign keys in some cases can be null, and that's dependent upon the particular issue that that table is trying to implement. Another concept you often hear about with a relational model is the idea of transactions. Transactions are logical units of work. When we interact with the database, we're going to be creating transactions and ultimately working with this concept a lot. In database terms, this often involves several manipulation operations, such as insert, delete, and update. These are three SQL keywords which we're going to use heavily when we get into our SQL portion of our course. The transactions are a group of operations. Could be one, could be many. As such, transactions are what are considered atomic, meaning whether it's one operation or many operations, they will execute as all or nothing. Either all of them will work or none of them will work. Commit and rollback are two keywords that we're going to hear a lot about with transactions. You can think of commit as being analogous to the idea of save. The use of a commit statement tells the database to save any changes to the data which have occurred since the transaction began. The transactions typically begin with a first manipulation operation, like insert, update, or delete. Depending on the system you're using, this may be a little bit different. You may need to actually issue a command that says start transaction. Now, users can abandon or undo any changes by using the rollback statement. This is kind of like undo is in Microsoft Word. It will undo any changes since the transaction began. Transactions are important for data integrity. Now, why we say this, when we talk about data integrity, we're talking about the assurance of valid data. Well, transactions are durable. Once you've issued a commit, those changes are guaranteed to be saved to the database. If you don't issue a commit, they're not saved. Transactions are also isolated, meaning that as multiple users use the database, often they want to work in their own little bubble until they're ready to save all their data. Transactions fulfill that idea by isolating themselves. The changes made are only visible to that user until a commit has been issued. Once that user commits, the rest of the world can see the changes. This allows the user to make multiple changes and then save them all at once.